Hello everyone, welcome to my channel. My name is Ali and this is going to be the first content video that I ever make. Definitely not the last. And this video is going to be one of 3 videos that I will make. So they're gonna be part 1, part 2 and part 3. This is part 1. In all those parts, like in those 3 videos, I will show you guys a full flight with the Boeing 737-800 from start to finish, from making the flight plan, reading the flight plan, starting up the Boeing 737, configuring it, taxiing, departing, cruising, then landing, of course. But it is going to be on 3 parts. In this part, I'm going to show you guys how to start up and configure the aircraft. Prior to that, of course, have a look on the flight plan, understand a few things about the flight plan, and so on. With that being said, just to let you guys know, I'm not a content creator, nor I'm planning to be a content creator, in the sense of I'm not going to dedicate myself or my time to create contents about aviation. Thing is, I'm an aviation enthusiast. I'm self-studying all aviation related subjects, especially piloting. I'm self-studying for piloting, so I'm not yet a pilot, but soon enough I'm sure I'm going to make my way into one of these amazing cockpits. So it is not easy. It is difficult thing to do. Don't get like I'm going to show you everything, and don't think that being a pilot or flying the Boeing or even the Airbus is something as easy as it is going to be shown in this video. It is difficult. There's a lot of factors to take into consideration. Yeah, so it is not an easy path, but I am not made for easy, and one day I will be pilot. So the reason why I'm making this content is kind of like rehearsing what I'm studying, like a refresher for whatever I'm studying, and like to keep myself in the loop, and it is a good practice as well. These simulator are really nice. I have a real representation of the cockpit of Boeing 737-800. All the buttons are working, everything. It is actually a very realistic simulator. I'm using the X-Plane 12 simulator. Okay, so with that being said, let's move on. I will try to cover as much as information as I can within this in all my videos, just to make it more beneficial. And let's get started. So here is the Boeing 737-800 checklist. This is what the pilots have on board, and kind of like reads from it when they want to check everything. So I'm going to do things from my memory, but I will go back to this checklist and I will confirm that I have done all the parts of the checklist. This is the checklist, and let me introduce you to this iVow network. So I am currently connected to the iVow network, and I have made my flight plan. This is my flight plan. Quite big, as you can see, a lot of things here. We will go through the most important parts of the flight plan. This is the website I used to make the flight plan, and our journey or our flight is going to be from Larnaca airport in Cyprus to Beirut International Airport. This is our route, and this is our alternate is going to be Damascus airport. So this is the flight plan. This is the virtual sky of the IVAO network. So when you see this shaded area, it is actually an ATC, air traffic controller, that is logged in to the network and acting as an air traffic controller. So I chose this flight because there is an ATC, so that I can also show you how pilots take clearances from the ATCs and all. So I am going to be here. I am using the call sign Prt1. This is my airplane on the network, Prt1.738, going to Beirut. So notice the red represents an ATC logged in as a tower, and those shaded area as a control area. So ATC has actually layers. It's not like one division who's controlling all the traffic. So there's layers of ATC, starting with the delivery, and then ground, and then it's going to be the tower, and then the departure or approach, and then the area control. So each one of those has different responsibilities to attend to. The first line of contact is going to be with the delivery. So here we don't have any delivery or tower or whatever, so I'm going to be in contact with the area controller. And in the IVAO, the area controller can in fact take over all the other layers, because it's still a simulation and it's not a real world, but it is different in the real world. There has to be dedicated ATC at all times. So I'm going to be connecting to this ATC to speak to and take clearances. This is the frequency, as you can see, 126.3 is the frequency which I need to enter to be able to speak to this ATC controller. So with that said, now I'm on the network, I'm online, my flight plan is ready. This is my flight plan. So let me first connect to the controller. We said it's 126.3 for the controller, and I'm going to show you how we take clearances. Okay, so this is Nicosia radar, so I'm going to address him by this, and it goes like that. Nicosia radar, very good evening. This is Prt1 requesting IFR clearance to Beirut International Airport. Now I have asked for the clearance, and I will wait for him to give me an initial clearance for my flight.
Prt1, good evening, Nicosia radar. You are clear to Beirut. Flight plan route Emily 1 Whiskey departure. Climb flight level 150, and your squawk code is 6703.
So now I will read back the clearance to the ATC. Always pilots have to read back the clearances. Clear to destination Beirut International Airport via Emily 1 Whiskey. Climb to flight level 150 and squawk 6703, Prt1.
Prt1, my mistake, Emily 1 Delta, out of runway 22.
Okay, so he made a mistake and he's correcting. Copy that. Clear to destination Beirut International Airport via Emily 1 Delta, runway 22. Climb flight level 150 and squawk 6703. Prt1.
Prt1, feedback is fully correct. Larnaca QNH 1010, cleared for push and start on Lima Alpha.
Copy that, QNH 1010, cleared to push and start on Lima Alpha, Qatari 426. Okay, so what happened now?
Alpha 13 Juliet Charlie, welcome to Larnaca.
Let me just...
Gate of your choice and report on block.
We'll report on blocks and on our choice. Less correction. Haifa 130, thank you.
Just going to reduce the volume so that I can speak clearly and you can hear me. Okay, so what happened that he gave me the initial clearance, and I will show you where we will put all this. Let me first introduce you to the flight plan. So this is the flight plan, the origin, destination, Qatari 426. We have here some important data that we later going to be enter into the
Nicosia control,
our airplane.
We're on block.
We have the zero fuel weight.
Thank you very much for the arrival into Larnaca.
Just
Hope to
take
see you
off
next
weight.
time. Have a wonderful and great night. Bye bye.
Okay, our flight level assigned to us
Thank you
is
for
150.
flying. Your flight plan is closed F01. You may leave that.
Okay, so our flight level is 150, which is 15,000 feet. It's a short flight, so we are not, we won't be able to climb more than that. Here's our fuel information. So our block fuel, which is the fuel that we will need in the entire flight, even in the entire flight with the reserves, is going to be 3,737 kilograms of fuel. Our reserves is going to be 2,014 kilograms of fuel. Of course, this is included in that, and this is in case of a go around or we have to divert to our alternative airport, which is Damascus. This is the route for the alternate destination, and this is our main route. So notice the ATC gave me clearance out of runway 22 for departure, MLE 1 Delta. This what the ATC gave me, and it is there in my flight plan. What else we can see here? Some data that we are gonna need down the line. So let's get to it. Okay, now we get into business, as you can see. So first, before I start, let's make things clear. I'm not a pilot, and I may do some mistakes along the way of configuring the airplane. So if there is any pilots watching, please be easy on me. If you notice anything wrong and you like to correct me, please leave a comment, and I will look into that, and I will appreciate the comments. So another thing, I don't know if I mentioned that before. In real world, pilots do way more than what I'm going to do. They go through a lot of complicated calculations that they do that I cannot do now because I'm in a simulator. So we are assuming that my flight plan is whatever I'm going to have actually on my on my aircraft. Whether in real world a lot of things differs, like the load sheet, center of gravity, and a lot of things sorry, will differ. Which then the pilot required to do. I don't know what happened with me. Okay, pilots were required to do more calculations to be as accurate as possible. Shout out to all pilots. They are doing a great job keeping us safe in the skies. Alright, so let's get to it. In this tutorial, I'm going to show, I think, about 70% of what pilots do on a Boeing 737 in terms of setting it up and configuring it and do the takeoff and landing later. Okay, so first things first, we need some power, and here we have the battery panel and we have this guard open. Once we close this guard, the battery will go to the on position and we will have power. Now notice we are running on the battery, so the battery does not supply the entire systems with power, so it will supply only the essential systems and mainly the left side, the captain side of the cockpit. So with that, now we have this. I'll close also emergency exit lights, and then what I like to do, one of the first things I like to do is turn the IRS to nav, because the IRS takes time to align, so I would like to do that step early on to give it time. Notice now we have some systems on, and now we don't want to drain our battery, so we would like to have another source of power to continue the configuring of the aircraft. In some airports at the gates they will have external power source that they can hook it to the airplane and give it a power. Another way is to turn the APU on, which is a third engine located at the back of the aircraft. I will not use that now. There is another way which I can request a GPU, which is an external power source, and as you can see here, ground power available, and we switch to ground power. Now we will have all the system active and ready, and I will start configuring the overhead panel. So we did the IRS, switch on the yaw damper, so we go top to bottom, left to right, and we're checking. Everything seems to be okay. No smoking sign on, fasten seat belt on, all is okay. And here are the packs. Actually this is the air conditioning system of the aircraft, and also it can be known as the pressurization panel. So we set it to auto and isolation valve to auto as well. Our flight level, as we see in our flight plan, is going to be 150, so we are going to change this to 150. Landing altitude, or the elevation of the runway that we are going to depart or land at. Usually it's the landing. We don't really need it much in the takeoff. In Beirut it's nearly 0, so we keep it at 0, the runway elevation, and this light set to steady. Overhead panel for now configured, can be considered as configured, and I will carry on with other things. So now for fuel and balance payload, now we will request the fuel. As we see here, our block fuel needed is 3,737 kilogram. So fuel 3737, and our payload is, again from the flight plan, is going to be 13.9. Here things are easy in the simulator. It will just distribute the weight automatically and make your life easier, but pilot's life is not this easy. Okay, so we call the fuel truck. The fuel truck is refueling. Says okay, overhead panel is fine, this is fine. Now we go to the FMC setting, or MCDU. So notice now it is giving me nav data out of date. It's because I don't have the latest nav data downloaded. It's not a big deal as a simulator. It is a big deal in the real world, but in the simulator we can just ignore it. FMC. First we are in the ident, which is identification page we make sure of our airplane 737-800 winglet, and then we go to POS init, which is position initialization. Our location now is Lima Charlie Lima Kilo, which is our origin, Larnaca Airport, and I am standing at gate 11A. Now we need to tell the IRS our exact position. We go next page and we grab our position from the GPS. Usually they use the left GPS, go previous, and set it in the IRS position. Now we have told the IRS where are we exactly. Next step is we go to route. Now as the aircraft already know that we are in Larnaca, it's showing me here the origin. I set it here. Our destination is Oscar Lima Bravo Alpha Olba, which is Beirut. My flight number is 426. CO route, which is company route. It's not really that it's not we can ignore that in simulator. We don't need to do anything here. Runway. Now instead of entering our departure runway here, we're going to go to the departure arrival page. Go to departure. Our departure runway is 22 as per the clearance given, and our SID, which is standard instrument departures, is going to be Emily 1 Delta as instructed by the ATC and as we have in the flight plan. Then we go to route next and we start inputting the route. Since it is a short flight, there's not much to be entered. So Emily, after that R19, okay, R19, and okay, so I have done a mistake, I think, because I noticed something. Okay, 22 Emily 1 Delta, this one. I pressed the wrong SID. Okay, we can rectify that. So Emily 1 Delta route. Then next, notice here Emily. It was showing something else, that's why I got confused, and I just noticed that I entered the wrong SID. So R19 is the airway on the left. Oh, what's happening? 19. On the left are the airways, on the right are the waypoints. Kukla is our waypoint after R19. And this is an arrival route, or we can call it STAR, standard arrival. So we go again to the departure arrival, to the arrival on Olba. We select our arrival runway, which is 16, and we select the STAR, which is Kukla 1X route. Now next we can verify that we do not have any discontinuity, then activate and execute. Now notice I have did the execute. In real world the other pilot should come and cross check all this information, and then the execute button is pressed. Since I'm going to be the only one flying this airplane now, I'm going to just execute. Okay, so here route 2 is our alternative destination, which is going to be OSDI Damascus. So I have never entered an alternative destination route. Okay, I'm just now kind of like improvising. Or I don't know if I'm doing the right thing, but yeah, whatever. This is route 2 for the alternative. Not sure if I'm doing the right thing, but yeah, I'm just improvising. And as I said, I'm doing this content to learn, to rehearse, to just get a hold of things. Okay, so going back to route 1, this is our main route. Everything is fine through the legs. Also, I can see that I do not have any discontinuity. Okay, perfect. So next is Prt1, which is performance initialization. Now we carry on and we enter the other data. Cost index 16. So what is cost index? So cost, let me put it this way, the higher the cost index, the faster the airplane is going to travel, and the much fuel is going to be burned. The lower the cost index, the slower the aircraft is going to travel, and the lower fuel burn. So it actually depends on the airline whether they favor money over time or time over money. It depends on their operation. Reserves, they are going to be 2.0. Zero fuel weight is going to be 5.5. And our fuel, let's just leave it as 3.7. Our flight level is 150 as we've seen before. So cruise wind and temperature, we are going to take them from the flight plan. We go down to this point where it says top of climb, and we take the wind data from here. 290 degrees at 21 knots, 290 degrees at 21 knots, and the temperature is going to be -10. M stands for minus 10. Our transition altitude is 13,000 feet. I'll talk about that later. Execute. Again, whenever there's an execute to be done, the other pilot should verify and cross-check all these things. Next is N1 limits. Basically what we are doing now is trying to derate the engine, trying to find the sweet spot at which we are going to give the engine sufficient power to accelerate down the runway and have sufficient speed to lift and take off without the need of giving it full power. This is good for fuel saving, it's good for environmental purposes, it's good for for the engine life, and also if we are taking off above residential area, it kind of reduce the noise, so it is more convenient. So to do that, we have to calculate the takeoff performance. I have this tool here to calculate the takeoff performance. We will enter the required data. We know that our runway is 22. It knows the length of the runway, you can see here. Our takeoff weight from the air, it took it already from the flight plan. Our takeoff weight 59. Sorry. Flap setting, keep it optimum. Thrust setting optimum. Bleed setting auto, and anti-ice I'm gonna keep it off because we are not gonna use any anti-icing. Our temperature is 21. Again, it's taken it from the real world. Actually, this network takes all the data from the real world weather and data. So in pressure we use hectopascal, and as you remember, the ATC gave me clearance and he said the QNH is 1010, which is shown here. Surface condition of the runway is dry, and we calculate. Sorry. Okay, so what we need to look at is this outputs. Flaps 5, usually it is 5. This most of the time it's 5. It depends on the runway length, runway condition, takeoff weight. A lot of calculation determines if we need more flaps or 5 is just enough. So our takeoff thrust is set as is calculated to be takeoff 2, the rate 2, so we are going to choose this one. Notice the N1 will drop, and when we set the cell temperatures 48 here, it will even drop further. 48. So now we can take off with 87% of N1. Instead of giving it full power 100%, we can go 87 and we can actually perform the takeoff at this power. Okay, next is takeoff. Flaps we set 5 as per the calculations. Center of gravity is going to be this much, and I'm going to need a trim of 5.25. Now this is the trim wheel, and this is where I'm going to set my trim. So it says 5.25. It's somewhere there at 5.25. Okay, now these speeds. Okay, notice it's not much different from what the FMC is showing. 133, 134, 138, 133, 133, 138. Okay, if it differs more than 1 knot, then we use this one. So 133 is, we are going to put that. VR, let's keep it at 134, and for the V2 let's put 141. Okay, now we'll lock this information in, and we now switch to the MCP. Now remember this speed 141. I'm going to enter it here, 141, and engage the auto throttle. The auto throttle is kind of like the cruise control in modern vehicles. It can be in any of our vehicles. It kind of like control the speed and keep the speed at the desired or at the required speed as set in the FMC, or as you can set here. So auto throttle armed. Flight director on copilot side first to make it master, because I'm going to flying at this side as first officer, not this side as captain. Okay, first flight director on first on my side, and then captain side to make my side master. And then now we start configuring the MCP again. He gave me, if you remember, the ATC gave me clearance to climb directly to my flight level 150. Sometimes they give initial climb and then they clear you to your flight level, but in this case he just gave me a straight ahead clearance to go to my flight level. The heading is going to be the same as the runway heading. Our runway is 22, so in Larnaca runway heading is 220. So about the runway, I'm just gonna give you a quick brief how the runways are named. So actually runways are named based on their headings. So runway 22 is going to be anywhere between, imagine the compass in front of you. It's a circle. Imagine a circle where 0 is at the top, north, and 180 is at the bottom, north and south at the bottom, where 90 on the right, east, and 270 on the left, west. So in each heading, with the runway, if the runway is heading, let's say 221, then we use 22 as the name of the runway, or 222 or 223. I guess there's, I think if the runway heading is 22, it can if the runway name is 22, it can be the heading of it can varies from 215, I assume, to 225, something like that. If I'm not exactly sure on that, but it is 99% correct. Runway 16, it means the runway heading is 160 or 161, 162, 3, or 155, 156, in that range. When you see a letter next to the runway, it, for example, 16L, 16L means left, so it means there's two runways in the same airport at the same heading, but then they differentiate between them with, they give them sides like left and right. If there's two runways heading on 160, so the one on the right is going to be 16R and the one on the left is going to be 16L, which means left. So basically this is how runways are named. Okay, so before we forget, let me just set the squawk as the ATC advised. My squawk was 6703. I noted down 6. Whenever you are taking clearance, it's better to note it down. 6703. And I turn this knob to TARA. Okay, continuing here. Runway heading set here. Initial climb, flight director. Okay, our QNH, which is the pressure, 1010. I control it from here. 1010. Our minimums, it differs from place to place, from airport to airport, but also it depends, I think, on the company procedures. But for the sake of the video, let's keep it on Baro 200. Baro 200, it's on radio. Baro 200 for the minimums. Set auto brake to RTO. This is in case the pilot decides to reject the takeoff, the auto brakes will apply brake automatically. Because I prefer, I don't know if this step is required, but I prefer to set the course of the landing runway of my origin airport, which is 40, because we are on runway 22, so the opposite, it's one runway here. From one side it's facing 220, from the other side it's facing 040. This is in case I need to go back for some emergency or anything. I have the course set ready for the landing runway at the origin. It's not gonna make much of a difference in our case here in Larnaca because there's no ILS system installed on the runway. This is very important. If there is an ILS installed, you cannot intercept the ILS if the course is not set correctly. What is ILS? It's instrument landing system. I'll speak about that in the part 3 where I land this aircraft in Beirut. So we make sure we have done everything. We set our MCP, altitude, heading, speed, everything. Alright, here. Now we perform some tests. We test all the lights. All the lights are working. All the lights are working. These pilots have to do this test. Check all the lights in case if there is any LED burned out or any light burned out. Okay, lights are good. Let's test our fire alarms. Engine fire alarm. We observe here that the lights is illuminated. Okay, test is performed. Same thing here. Okay, and then we have one more test to do. Also, this speed warning tests and stall test. As you can see, the stick shaker, you can hear the stick shaker. We have to make sure that these systems are working. In case something happens mid-flight, we need to be able to hear and feel the warnings. Otherwise we might miss that something is wrong with the aircraft. Okay, so MCP is set. This is set. Let me see here. All the details are fine. We're here. Let me see. We still have ATC. Very good. Now I am cleared for pushback and start the engine, as I have given initial clearance to do that. But I will end this video, this part now, as I have covered the startup and the configuration of the aircraft, and the next step is going to be pushing back and starting the engine. So thank you very much for watching, and I hope you find this video beneficial to you, and thank you again for watching, and see you in part 2, how to push back and take off to the cruising level. Have an absolutely fantastic day.